Right, let's kick off this deep dive. And today we're going to be looking at AI chip performance.
Okay.
Specifically, we're going to see if this AMD MI300X can live up to all the hype.
Yeah.
We're going to be looking at a December 2023 report from SemiAnalysis. And they compare the MI300X head-to-head with Nvidia's H100 and H200 GPUs.
Yeah.
And we're looking at training benchmarks.
Gotcha.
So, is the MI300X a game changer, or is software holding it back? That's what we're here to find out.
Well, I think what's really fascinating about this report is that it, goes beyond just those theoretical specs on paper. It looks at those real-world training scenarios, which is where the rubber meets the road for AI.
Right. So let's talk about the hype.
Yeah.
When the MI300X launched, it seemed like AMD was, going to really shake things up on paper. It boasts some pretty impressive specs. 1027 TFLOPs for FP16 compute. It's got a massive 5.2 terabytes per second of memory bandwidth.
Wow.
And 192 gigabytes of HBM3 memory.
Those are big numbers.
Yeah, these are huge numbers.
Yeah.
And those numbers look even more impressive when you compare them to what Nvidia's offering.
Yeah.
The H100 comes in at 899 TFLOPs. 3.35 terabytes per second for the memory bandwidth, and 80 gigabyte of HBM2E memory.
Right.
The H200 offers 6.8 terabytes per second, and 141 gigabytes of HBM3 memory.
Gotcha.
So just based on those numbers alone, you would think that AMD would be dominating.
Right. Yeah, especially since they're usually known for being more affordable.
Yeah.
So it seemed like they were offering a winning combination, right?
Yeah.
Like potentially better performance at a lower cost.
Yeah, you would think.
And, analysts were even predicting that AMD could grab a significant chunk of the market share, like maybe even hitting 10, 12% by 2027.
Wow.
Up from their, mid-single digit share in 2023.
But then this SemiAnalysis report throws a wrench in things.
Well, yeah, the benchmark data, it tells a bit of a different story. It seems that while the MI300X has the hardware muscle, like it's got the power, its software might be its Achilles heel.
Oh, the software angle.
Yeah.
That's where things always get interesting.
Indeed.
So what are we talking about here?
Well, the core argument of the report is that AMD's software stack is what's holding back the MI300X. And they point to a variety of issues.
Like what?
Well, from bugs, performance bottlenecks, to a lack of user-friendly-ness, and then a reliance on what they call forked libraries.
Okay, wait, hold on. Forked libraries.
Yeah.
What does that even mean? Is that like copying somebody else's homework?
It's a pretty good analogy.
Okay.
So essentially what AMD's doing is they're using a tool called Hippify to convert NVIDIA's CUD code, which is like the language used to program NVIDIA GPUs into their own HIP language.
Gotcha.
And it's a way for them to kind of leverage NVIDIA's existing software ecosystem.
And speed up their own development.
So it's a shortcut.
Yeah, a shortcut.
That makes sense, but I could see how it could be risky.
Yeah.
What if NVIDIA's code isn't the best fit for the MI300X's architecture?
Right.
It's like building a house on someone else's foundation,
That's a great point.
You're limited.
And the report actually touches on that. It raises the question of whether AMD can really innovate and differentiate themselves if they're relying so heavily on their competitors' work.
Yeah, okay, so let's get into the specifics.
Okay.
What kind of performance issues did SemiAnalysis uncover?
Well, they ran a whole battery of tests focusing on key areas like GEMM performance, memory bandwidth, and, real-world training workloads. And in many cases, the H100 and the H200 consistently outperformed the MI300X.
Wait, so the MI300X actually performed worse?
In some cases, yeah.
Even though it has higher TFLOPs and bandwidth on paper.
Oh, that's where the software comes in? I'm confused.
Yeah.
How is that even possible?
For example, let's talk about GEMM.
Okay.
So GEM stands for General Matrix Multiply.
Okay.
It's a fundamental operation in AI training.
Gotcha.
Basically, it involves multiplying large matrices of numbers.
Right.
And it's something that GPUs are designed to do well.
So how did the MI300X fare in these GMM benchmarks?
Not great.
Really?
Despite having higher theoretical TFLOPs, the MI300X was about 10% slower in BF16 GMM benchmarks. And a whopping 22% slower in FP8.
Wow, that's a big difference.
Compared to the Nvidia GPUs. And it gets worse.
Oh, no.
They actually discovered a bug in AMD's PyTorch implementation.
What's a bug? Right out of the gate.
Yeah, where 2 different GMM libraries were being used, and they were performing inconsistently.
Not a good look.
No, it's not a good look.
So it really speaks to that larger issue of AMD software maturity.
Yes, it does.
What other kinds of bugs or usability issues are we talking about here?
So for example, to get decent performance out of the MI300X, testers actually had to create custom Docker builds.
What's a Docker build?
You can think of it as like a pre-packaged software environment.
Okay.
And these custom builds took hours to compile.
Hours. Oh my God.
They also had to manually set dozens of environment flags.
What's an environment flag?
You can think of it as settings that control how the software behaves.
Okay.
And sometimes they're necessary.
Right.
But it seems like AMD was using them as a crutch to compensate for some underlying issues.
So instead of fixing the root cause, they're just adding more and more options for users to fiddle with.
Yeah, it's not very user-friendly.
No, not at all.
And it creates a lot of complexity for developers, making it harder to get consistent and reliable results.
Okay, so what was SemiAnalysis's recommendation for this?
So their recommendation was that AMD should bake those commonly used settings into the default configuration so that the out-of-the-box experience is actually usable.
Okay, all right, so bugs, clunky workarounds, general lack of polish.
Right.
But what about the memory bandwidth?
Yeah.
That was supposed to be a big selling point, right? A big advantage.
It was. And in that area, the MI300X actually did deliver.
Okay.
It did achieve higher memory bandwidth than both the H100 and the H200 as advertised.
So that's got to count for something, right?
It does.
Okay.
Higher bandwidth allows for larger batch sizes during training, which can significantly speed things up.
Okay.
However, in the grand scheme of things, the software issues kind of overshadowed this advantage in those overall training performance tests.
Right.
And that brings us to the heart of the matter.
Yeah.
Those real-world training workloads.
Right. Let's talk about those.
Okay.
What kind of models did SemiAnalysis use for their tests?
They used a mix of popular models that reflect real-world usage, such as GPT 1.5b, Llama 8b and 70b, and Mistral 7b.
Right. So these are the kinds of models that, developers are actually using.
Exactly. These are the ones that people are building AI applications with.
Okay. And I'm guessing the Nvidia GPUs still came out on top.
Unfortunately, yes.
Wow.
The H100 and H200 outperformed the MI300X on all the models they tested, often by a significant margin.
Wow.
And what's really interesting is that the performance gap was even wider in models that use something called non-causal attention layers.
Non-causal attention layers.
Yeah.
Okay, you're going to have to explain that one to me.
Okay, so think of it this way. Attention layers in AI models are kind of like filters that help the model focus on the most important parts of the input data.
Gotcha.
Non-causal attention layers are a specific type of attention mechanism that look at the entire input sequence at once rather than processing it step by step.
So the MI300X struggled with these more advanced attention mechanisms.
It seems that way, yeah.
Does that mean its software is missing some key features?
Yeah, that seems to be the case.
Oh.
The report also highlights issues with AMD's ROCm communication library.
What's that?
Which handles communication between GPUs when you're using multiple GPUs in a system. And it's just not as mature or well optimized as NVIDIA's NCCL.
Gotcha.
And that can really hurt performance in large-scale deployments.
I'm starting to see a pattern here.
Yeah.
Bugs, missing features, clunky workarounds, less mature software ecosystem.
Right.
It sounds like AMD has a lot of catching up to do.
They do, but to be fair, they are making efforts to improve their software. In fact, they've been actively collaborating with SemiAnalysis throughout this benchmarking process, providing bug fixes and custom software builds to try and boost performance.
So there's hope for the MI300X.
There is. SemiAnalysis included results from some of these custom builds and development branches in their report.
Right.
And while the performance is still generally behind NVIDIA, it does show progress.
Right. But custom builds and internal fixes are great for testing and debugging.
Yeah, absolutely.
But they're not a sustainable solution.
No, not for widespread adoption.
Right.
If AMD wants to attract developers and gain market share, they need to make their software as seamless and user-friendly as NVIDIA's.
It sounds like a tall order.
It is.
Especially given how far ahead NVIDIA seems to be.
Yeah.
I'm curious, does the report offer any concrete recommendations?
It does, for how AMD can close this software gap.
Yeah.
It basically boils down to 3 key areas.
All right, let's hear them.
Investing in talent,
okay,
rigorous testing, and strategic partnerships.
Very interesting.
We'll dive into those recommendations and explore the potential impact they could have on AMD's future.
Yeah.
In part 2 of our deep dive.
All right, so for now, let's leave our listeners with this question to ponder.
Okay.
If software can truly make or break even the most powerful AI hardware, what does that mean for the future of innovation in this space?
Think about it.
Think about it, and we'll be back soon to continue our exploration.
Sounds good.
Welcome back to our deep dive into the world of AI chips and software.
Yeah.
Before we, went to, well, I guess not a break since we don't have those.
Right.
We were talking about how these software issues might be holding back the AMD MI300X.
Right, and we were just getting into those recommendations that SemiAnalysis outlined for AMD to try to address those.
I'm really curious about these recommendations.
Yeah.
Especially since you said they were insightful.
Yeah.
Where do they suggest AMD should start?
So the first recommendation is perhaps the most straightforward.
Okay.
Invest heavily in software engineering, talent, and resources.
That makes sense. I mean, you can't really build a world-class software stack without a world-class team.
Exactly. AMD needs to attract and retain top-tier developers who specialize in AI, high-performance computing, and software optimization. And it's not just about hiring more people. It's about creating a culture that values software excellence. And empowers those developers to do their best work.
So it's a combination of attracting the right people and giving them the right environment to thrive.
Absolutely. The report really emphasizes that AMD needs to kind of shift its mindset and recognize that software is no longer an afterthought in the AI world. It's the foundation upon which everything else is built.
Right, because even if you have the most powerful hardware in the world, if you don't have the software, it's useless.
Precisely. And that brings us to that second recommendation.
Okay.
More rigorous internal testing or dog fooding.
Oh yes, eating your own dog food.
Yeah.
What does that actually look like for a company like AMD?
It means using their own software internally for real projects, just like their customers would.
Right.
It's about putting that software through its paces in those real world scenarios.
So it's like a stress test, but for software.
Exactly. And the report highlights several instances where AMD could have caught those critical bugs much earlier if they had been dogfooding their software more aggressively.
I can imagine how frustrating it would be.
Oh, yeah?
For developers to encounter bugs that could have been easily fixed.
Totally.
If AMD had just used their own software more thoroughly.
Yeah, it really hurts their credibility and their reputation in the long run.
Okay, so invest in talent. Rigorously test the software.
Right.
What's the third recommendation?
The third recommendation is perhaps the most strategic form partnerships, particularly with key players
interesting.
in the AI ecosystem.
Who do they have in mind?
Well, they specifically call out Meta as a potential partner.
Okay, Meta, the Facebook people.
Yes, but they're really one of the leaders in AI development, especially when it comes to those large language models.
Right, they're the ones behind Llama.
Exactly.
The open source language model that everyone's talking about.
That's the one.
Yeah.
And they've done incredible work optimizing AI models for training at scale. And the report suggests that if AMD can partner with Meta to get production level LLM training working seamlessly on their platform, it would be a huge validation of their technology and attract more developers.
Right, so it's about building credibility and momentum.
Exactly.
If Meta is willing to bet on AMD, then other companies and developers might be more likely to follow suit.
Precisely. And it's not just about Meta.
Okay.
The report also emphasizes the importance of engaging with open source communities like PyTorch and TensorFlow. Contributing code, working with those developers to optimize those widely used frameworks for the MI300X.
Right, so if the software tools that developers are already using work well on AMD hardware, they're more likely to choose AMD, even if the hardware itself isn't necessarily the absolute best.
Yeah, it's about creating that positive feedback loop.
Right.
The more developers use and contribute to AMD's software ecosystem, the faster it will mature and improve, which in turn will attract even more developers.
So these recommendations are all about playing the long game.
Yes.
Building a sustainable ecosystem.
Right.
Creating a virtuous cycle of improvement.
It's not about those quick fixes or flashy marketing campaigns.
Right.
It's about making a genuine commitment to software excellence and creating a platform that developers love to use.
Okay, that makes sense.
Yeah.
But I'm also curious about the bigger picture here.
Yeah.
We've talked a lot about the challenges facing AMD.
Yeah.
But what are the implications of all of this for the AI industry as a whole?
That's a great question. And I think this whole situation highlights a crucial truth about AI.
What's that?
Hardware is only half the story.
We've definitely been hammering that point home today.
We have, and for good reason.
Yeah.
As AI models become increasingly complex and data sets grow larger, the demands on software are only going to increase. And we're already seeing that with the rise of these large language models, which require specialized software and infrastructure to train and deploy effectively.
So in a way, the software is becoming even more important than the hardware.
In some ways, yes, the hardware provides that raw processing power.
Okay.
But it's the software that determines how effectively that power can be utilized.
Right.
It's like having a really powerful engine in a car.
Okay.
Without a skilled driver and a well-designed transmission, that power is useless.
Great analogy. So what does this mean for companies like AMD and Nvidia and other players who are trying to enter the AI chip market?
I think it means that the competition is going to be increasingly fierce.
Not just on the hardware front, but also on the software front.
Right.
Companies that can create that seamless and robust software ecosystem.
Yeah.
They're going to have a significant advantage.
It's almost like we're seeing a shift from a hardware-centric view of AI to a more holistic view that recognizes that critical role of software.
Absolutely. And that's going to have a profound impact on the types of chips that are developed, the way they're designed, and the features that are prioritized.
Okay.
We're likely to see more emphasis on things like programmability, ease of use, compatibility with those popular software frameworks.
So it's not just about cramming more transistors onto a chip or boosting raw performance numbers. It's about creating a platform that developers love to work with that can handle these increasingly complex demands of AI workloads.
Exactly. And that's why AMD's current situation is so interesting.
Right. They have a real opportunity to disrupt the market, but they need to make some fundamental changes to their software strategy if they want to succeed.
This has been really insightful.
Yeah.
I feel like we've gotten a much deeper understanding of that complex interplay.
Yeah, me too.
Between hardware and software in the AI world. And I'm really starting to grasp just how important this software ecosystem is.
Me too. And, you know, we haven't even scratched the surface.
Oh, there's more.
Of some of those more nuanced details.
You're right. There's still more to uncover.
Yeah.
So let's dive into those details next.
Okay.
We'll explore those specific examples of the software issues that SemiAnalysis encountered, analyze the performance of those different networking configurations, and discuss the implications of AMD's reliance on those forked libraries.
Sounds good.
Welcome back to the deep dive. We've been talking about AMD's quest to take on Nvidia in the AI chip arena.
Right.
And it's clear that software plays a huge role.
Yeah, for sure.
You mentioned some really interesting nuances in the SemiAnalysis report.
Let's get into those specifics because, you know, sometimes those most revealing insights are hidden in those details.
I'm all ears.
Okay, so
what kind of quirks did SemiAnalysis find?
Well, one issue that really stood out to me involved AMD's implementation of something called flash attention.
Okay, I have to admit, I'm not familiar with that one.
Okay.
Could you explain it like I'm 5?
So imagine you have a massive amount of data to process.
Okay.
Like a giant library full of books.
Okay.
Flash attention is a technique that helps AI models quickly find the most relevant information in that data, kind of like a super efficient librarian.
Gotcha.
It makes those attention calculations much faster, which is crucial for training large language models.
Okay, that makes sense.
Yeah.
So what was the problem with AMD's implementation?
Well, for a while there, the part of the software responsible for flash attention was running incredibly slowly.
Really?
Way slower than it should have been. In fact, it was so slow that a modern CPU could have calculated the same thing faster.
Wait, slower than the CPU?
Yeah.
I thought GPUs were supposed to be way faster.
You're absolutely right, they are.
Okay.
And that's why this finding was so surprising.
So nobody at AMD seemed to notice this bottleneck.
It seems that way, yeah.
Wow.
Until SemiAnalysis dug deep into that performance profiling and identified the culprit.
Okay, so what was it?
Well, it turned out that a specific part of that flash attention calculation, the backwards pass, was taking way longer than it should have.
So it wasn't like a complete failure.
Right.
But a specific part of the process was really gumming up the works.
Exactly. It's like having a super fast car with a flat tire.
Yeah.
You're not going to get very far.
You're not going anywhere.
No matter how powerful the engine is.
Right. And it highlights that recurring theme that we've been discussing, the importance of thorough testing and dog fooding.
Exactly. Using their own software internally to catch these kinds of issues before they reach customers.
Okay, so flash attention, slow tire on a fast car.
Right.
Any other interesting quirks?
Another one that stood out involved the way AMD's PyTorch implementation handled the torch.compile function.
Okay, now there's another term I'm not familiar with.
All right.
PyTorch, torch.compile. Break it down for me.
So think of PyTorch as like a toolbox full of powerful tools for building AI models. And torch.compile is like a special tool that helps make those models run faster and more efficiently.
Okay.
It's like sharpening your tools before you start building something.
I'm following. So what was the issue with AMD's implementation?
So there was a bug that caused a hard error. When this torch.compile tool was used in conjunction with certain attention layer calculations.
There's a compatibility issue.
Yeah, it's like trying to use your newly sharpened saw only to find out that it's completely jammed.
That's so frustrating.
Yeah, it is.
Did they ever fix it?
Yes, but here's the kicker.
What?
The fix for this bug already existed in internal AMD builds.
Wow.
But it hadn't been released to the public for months.
So the solution was right there.
It was right there.
Just sitting on a shelf somewhere.
Yep.
While developers were struggling with this bug.
Yeah, it's a real missed opportunity.
It is.
And again, it points to that lack of focus on the end user experience.
Right. If they want to be a serious contender in the AI space, they need to make their software stable, up to date, developer friendly.
Yeah, for sure.
So bugs, slowdowns, delayed fixes, anything else that trip people up.
Remember those environment flags?
Yes, those sounded pretty complicated.
They can be, and that's part of the problem.
Okay.
SemiAnalysis found that you needed to set dozens of these flags.
Dozens. Seriously.
Just to get reasonable performance out of the MI300X.
Why so many?
It seemed like AMD was relying on these flags as a way to work around those underlying issues in the software rather than addressing those root causes.
So it's like using duct tape to fix a leaky pipe.
Exactly.
Yeah, it might work temporarily, but it's not a real solution.
It's not a real solution.
So bugs, performance bottlenecks, complex workarounds.
Yeah.
It starts to sound like AMD has a lot of ground to cover.
They do.
If they want to catch up to Nvidia.
Yeah, but it's not an impossible task.
Right.
Remember those recommendations we talked about earlier?
Right.
Investing in talent.
Right.
Investing in talent. Rigorous testing, strategic partnerships.
Yeah.
These are all steps in the right direction.
Right. But it sounds like they also need to make some fundamental changes to their software development process.
Yeah, absolutely. And one area where they could really benefit is by moving away from their reliance on those forked libraries.
The copying homework strategy.
Right.
But I'm still a little fuzzy
Yeah.
on how that works in practice.
Okay.
Can you give me a concrete example?
Sure. Let's talk about those multi-node setups.
Oh.
Where you're using multiple GPUs working together to train those really large models.
That's where things get really serious in terms of performance.
Exactly. And this is where AMD's reliance on those forked libraries becomes a real liability. They're using a communication library called ROCm, which is essentially a modified version of NVIDIA's NCCL library.
So they're taking NVIDIA's code and tweaking it to work with their own hardware.
Yes. And while that can be a quick way to get something up and running, it also has some major drawbacks.
Like what?
Well, for one thing, it means that AMD is always playing catch up. They're inheriting NVIDIA's design choices, which might not be the best fit.
Right. It's like trying to build a skyscraper.
Yeah.
Using blueprints for a suspension bridge.
Exactly.
You know, the basic principles might be similar,
right,
but the details
are totally different.
And the performance differences can be significant.
Okay.
In SemiAnalysis's multi-node tests, the H100 consistently outperformed the MI300X.
Okay.
Sometimes by as much as 10 to 25%.
Ouch. That's a huge gap when you're talking about training those massive AI models that can take, days or even weeks to run.
Exactly. And it really highlights the importance of having a software stack.
Okay.
It's specifically designed and optimized for your hardware.
So what's the takeaway here?
I think AMD needs to invest in building their own unique software ecosystem.
Okay.
One that plays to their strengths.
Right.
And differentiates them from Nvidia.
Yeah.
So stop trying to be a Me Too player.
Exactly.
And forge their own path.
Find their own voice in that AI software world.
Right.
And they need to build a platform that developers are excited to use.
Okay.
That's the key to that long-term success in this rapidly evolving market.
This has been an incredible deep dive.
Yeah, it has.
You've covered so much ground.
We have.
From those benchmark results to those software challenges to strategic recommendations. I feel like
I agree.
We've gained a much deeper understanding, not just of the hardware, but the entire ecosystem that surrounds AI.
I agree.
And it's clear that software is no longer just a supporting player.
Right.
In the AI world, it's the conductor, the orchestra, the architect of the grand design.
And if AMD wants to play a leading role in this exciting new era of AI, they need to make sure their software is hitting all the right notes.
Well, we'll be watching closely to see how they respond to these challenges. And for all of you listening out there, we hope this deep dive has inspired you to think critically about the role of software in shaping the future of AI, because ultimately it's the creativity and ingenuity of developers
for sure
that will unlock the true potential of this transformative technology.
Absolutely.